Hi guys, now we're going to look at practice E in your note packet, and for practice E we're going to solve the final velocity, which is dependent on initial velocity, acceleration, and displacement. Now the last problem we solved for final velocity, which was dependent on acceleration, initial velocity, and time. So we have a little different expression here, and VF squared equals VI squared plus twice the acceleration times the distance in which that acceleration occurred. Alright, so let's practice using this expression. So start off with our givens. What are our givens in our problem? A car traveling at, so at gives us a clue about is that initial or final velocity. 7 meters per second accelerates uniformly at a rate of 8 meters per second for distance. So if it's at, that's going to be our initial velocity plus 7.0 meters per second. Accelerates uniformly at a rate of A equals 0.80 meters per second squared for a distance of 245 meters. So my displacement is 245 meters. Okay, so I don't think I've missed any givens. And so what is the velocity at the end? Now we need an equation. And so we have an equation that says the final velocity of an object squared is equal to the initial velocity squared plus twice the acceleration times any distance that acceleration occurs. All right, so let's go ahead and solve this expression for VF, which says here we have VF squared. If we want to know what VF is, we're going to simply take the square root of the initial velocity squared plus twice AX. So be sure you do all this. You square the VI, you multiply, add, then square root. Keep your order of operations. So we're going to substitute in, and now we're going to say the final velocity of this object is equal to the square root of VI, which is 7. Don't forget to square that, plus twice the acceleration, so 2 times 0.8 times the displacement, 245. So my final velocity equals, and we'll just all that in our calculator, and so I'm going to do this second portion first. So we're going to go 2 times 0.8 times 245 equals, all right, 392, and I'm going to make a little note of that. All right, and so then we'll go 7 squared plus 392 equals, and we're going to take the square root of 441. The final velocity equals 21. And that's a unit of a meter per second. Now that's reported to two significant figures. We got two significant figures in this choice, and we have two significant figures in our given of 7. So this is our correct response. Now you'll notice that I changed choice B, practice problem B, around a little bit because this is a common problem. And it's, again, the same set of givens, but instead of solving for final velocity, now we're going to solve for time. But we've also just solved for a final velocity, so we can now include that. Of course, we want to be careful about including any solved answer in a second problem, but it often decreases the difficulty of a problem, and in this case, that's so. So we're going to go ahead and use that. Initial velocity, 7 meters per second. Acceleration, 0.80 meters per second squared. And the distance, 245 meters. And the final velocity is 21 meters per second. So our equation, our unknown, got a little ahead of myself. These are our givens. Our unknown in this expression, okay? Our unknown in this expression is time. We're looking for time. Now we don't have an equation that says t equals. But we have a couple other equations, and we have one that is VF equals VI plus AT. And we used this one earlier. We solved it for time in an earlier situation. And so in this case, we can do the same thing. We can solve this expression for time. And so we're going to subtract VI from both sides. So we have VF equals VI plus AT. So we're going to subtract VI from both sides. And what we do is 1 to go to the other. So we get VF minus VI, and that cancels, equals AT. Divide both sides by A. And we see that the time it takes for the object to accelerate, to change its velocity based on that acceleration. So VF minus VI over T. So now we're going to come over here and we're just going to substitute it and get our final response. Substitute. So our final velocity, which we solved in the previous problem, 21 meters per second, minus, we should be able to finish, minus our initial velocity, which is 7.0 meters per second, divided by the rate at which this is occurring. I wrote a T here, I meant to write an A, which is 0.80 equals T. So T equals, so we're using our little calculator here, and of course we go 21 minus 7 equals, and then we divide that by 0.8 equals 17.5 seconds. And we see two significant figures in this given, 2 in that. So we need to report this to two significant figures. So I'm going to report this as 18 seconds. So the point of this question is, we have the same set of givens, and we're using a new given, a new solution, to solve for something different. And this happens in many cases. Always be careful when you're taking a solved answer and using it in another problem, because any mistake you make in the first problem, you would be carrying into the second problem.